Hello everyone. In this video, we will learn how to deal with counting problems which involve dividing up into groups which are not distinguishable. Well, let us recall that when we have n distinct or different objects, and we want to divide them into up to k groups, while k different groups, with first group having n1, the second group having n2, and kth group having nk elements or members. Then the number of ways we can do this is given by this n, choose n1, n2 up to nk, which in the formula it means that we have n factorial, n1 factorial, n2 factorial up to nk factorial. Here we are assuming that, well, the sum of the number of elements of the groups is equal to the total number, yes? But when you're using this formula, you have to note that you already know what is the group with this number of elements. So in other words, this place has already saying that has already been saying us that there is a group 1 which is distinct by some property, and I'm looking for n1 elements to put into that group. There is another group 2 which is different through some properties or some specific thing, for which we want to choose n2 elements and assign it there. And this one goes as on the group K. So in other words, the formula can be used. The formula can be used when all K groups are distinguishable. Well, distinguishable through some properties. Well, this property can be anything, like this property through properties or different assignments, different colors, and also maybe different number of elements. Because if a group is going to have one element, another group is going to have 10 elements, these are in nature different, distinguishable. No one is going to confuse group 1 with 1 element with group 2 with 10 elements. A different number of elements. But what if our groups are not, maybe all of them or maybe some of them are not distinguishable? So what if they are not distinguishable? So what should we do in that case? Obviously, we cannot go and use that n, choose n1, n2 up to nk formula, because we obviously know that that is only for distinguishable case. So here, the trick that we will introduce, I'll call it fake labeling. So what we do is that first introduce a fake labeling for the groups and make them distinguishable, and then use this formula. And then in the second step, we take care of that fake labeling. Okay, let's see this in an example, and then we see how this will work. There are 10 graduate students in the math department. They're going to play soccer, and they want to divide or form 2 teams with 5 players. Okay, so when you look at this question, right away, the first thing it should come to your mind is that the teams are indistinguishable. In other words, when you form these two teams, there's no way that I can say, well, this team I assume is special compared to other team. At least when it comes to counting, these are the same things. So there is no order, there is no specific color, say, to assign, or there's nothing that distinguishes this team from the other team. Okay? So what should we do here? So as I said, step 1 in these kind of questions is that introduce fake labels to teams. Well, say team 1 or team bread and team 2. Okay, so in that case, then I have 10 players, and I want to put 5 of them in team 1 and 5 other one in team 2. Okay, this is nice. So I introduce this fake label, and that way I can use that part of that formula. But then step 2 is that get rid of the fake labels. So how I'm going to get rid of that? Well, see, if I choose 5 players and another 5 players, I now label them with team 1 and team 2. Yes. Now, if with the same number of the same members, if I do switch the places of team 1 and team 2, so it goes like their team 1 and team 2, then these two are going to be counted as different cases with the labeling. But when it comes looking at these guys, these 2 teams, both cases are the same case. We introduced the team 1, team 2, but these are exactly same way of forming these 2 teams with 5 players. So we have overcounted. How many times we have overcounted? First of all, overcounting means that we have to make our number smaller, because our fake labels introduce more overcounting. Now we have to get rid of that. Well, this overcounting can be solved by considering all permutations of the fake labels. Here we had 2 labels, and all the possible permutations are 2 factorial. So the number of ways to form 2 teams of 5 players out of 10 players is not 10 choose 5, 5. It's 10 choose 5, 5 divided by 2 factorial. factorial. And in general, this trick will be what we would use in indistinguishable grouping problems. So to deal with indistinguishable grouping or groups, we always would do two things. Step one, fake labeling. Step two, getting rid of fake labels. So if you label and then using the fake label you make groups distinguishable, then you can use n, choose n1, n2 up to nk. Then to get rid of all these things, you have to divide this number that you find by all or the number of permutations of the fake labels. So I'm writing this a little bit more general, but you will notice what I mean. So in the previous question, over there we had only two fake labels and all the permutation was 2 factorial. And for example, if, let me just write this as an example, the number of ways to divide n different objects or distinct objects into k groups with m1 up to nk members, such that t of them, only t of them have same number of elements. So consider all the other groups that we want to form, they will have either different assignment or they will have different number of members. So the other ones are distinguishable. Only t of them are not distinguishable. In that case, we label those t groups with fake distinct labels, so that I can use this part. Then we have to get rid of that part, which means that divided by the number of permutations of the t fake labels that you introduce. So that will be t factorial, as we had in the previous example. In that case, t was 2. Okay, let's see this in an example, a little bit more general kind of example, and see how this works. 27 students are attending a Zoom meeting of Dr. X's online class. So Dr. X asks his assistant to divide the students into 5 groups. 3 groups with 5 students and 2 groups with 6 students. In how many ways this can be done? Okay, so here we notice that 3 groups of 5, these are not distinguishable. And 2 groups of 6, and these 2 are also not distinguishable. So, but note that we are not going to confuse any group with 5 with a group with 6 members. So these 2, when you look at these 2 category of the groups, these are completely distinguishable. But inside the groups of 5, There's nothing that we can distinguish between. So we introduce a step one, introduce fake labels. So what do we do? So 3 for the groups with 5, 3 fake label, 3 fake labels for groups with 5, and 2 fake labels for groups with 6. Okay? Then, well, in that case, I will have 27, choose 5, 5, 5, then 6, 6. Okay? Now, step 2, get rid of labels. Fake labeling. So, we know that we have to divide because that introduction of fake labels caused an overcounting. Now we want to divide and get rid of this overcounting. But we know that the permutations of labels can happen here. There are 3 fake labels for the 3 groups of 5. The number of permutations of those guys is going to be 3 factorial. And there are 2 labels for the groups of 6, yes? And we can permute those guys with each other and get 2 factorials there. So this way, you have counted basically all the permutations of similar fake the fake labels that we introduce in step 1 and get rid of that by doing that, dividing the whole number by that. So this will be our strategy always in the cases that we are dealing with groups which are not distinguishable, especially they will have the same number of elements. We need to do some examples. In next videos you will see some examples and how to deal with these cases.